So starting with section 3, we're going to be talking about mixtures. And a mixture is a combination of two or more substances not chemically combined. It's a physical mixture of substances. So that's the main topic for today. So questions that you should know the answers to at the end. How do mixtures and substances differ? Mixtures, like I said, are physical. Substances, a compound, is going to be chemically combined. Why are some mixtures classified as homogeneous? Some are classified as heterogeneous. What's the difference between them? And then how do we separate these mixtures? What methods are used for separating different kinds of mixtures? Vocab. Some I'm sure you've heard before, but maybe not all. Heterogeneous, homogeneous. Homo means same, hetero means different. Filtering, distilling, crystallization, that one you may not have heard of. And then sublimation and chromatography are the last two. So, getting started. A mixture is a combination of two or more pure substances, and technically a mixture can even be not pure mixtures, or not pure substances that are put together. The only thing is, when you have a mixture, each substance keeps its chemical properties. If I put salt in water, I have salt water. There's still salt, there's still water. They have not changed anything at all. So a mixture, they keep their own properties. If I make a fruit salad, I still have oranges, I still have bananas, I still have apples. They have their own properties. Homo, like I said, homo means same. So a homogeneous mixture looks the same throughout. If I look at the appearance, so my Diet Coke is a homogeneous mixture. It looks the same throughout. It has the same composition throughout. Everything is spread evenly and throughout the entire solution. Homogeneous mixtures are often called solutions, especially if they're mixed with a liquid. And even if they're not, technically air is considered a solution of carbon dioxide, nitrogen, oxygen. All of those that are mixed together, air would be also considered a solution. Air would be homogeneous. Everything is spread out. The composition is pretty much the same everywhere you go. So homo means same. The composition stays close to the same throughout the entire thing. Hetero means different. So heterogeneous mixture, the individual substances remain distinct. I can actually see it. So in a heterogeneous mixture, they're going to keep their same properties. However, I'm going to see it. So a fruit salad, an example of heterogeneous would be a fruit salad. Each are, like I said, oranges, apples, I see each part. Here the composition, so salt water. Looking at it, I don't see the salt. I see the clear substance. Looking at my Diet Coke, I don't see the caffeine. I don't see the white. It just looks like a brown mixture. So it's spread evenly. So homo, same, hetero, different. And very quickly then, we'll look at some, and I know this table is on your website. So if I click on this. So what would be a gas system from down here? All it's made out of is gases. The first one. So I would scoot that up. Gas liquid. So what has gases in a liquid? It's the oxygen and carbon dioxide. It's a oxygen and carbon dioxide in water. Liquid gas, liquid in a gas. Water droplets in the air. Liquid, liquid. Yep, last one. Solid in a liquid. First one. And air tank is an alloy, it's two metals. Submit. And yay, we have them. All right. So there's that just shows the different kinds of mixtures and solutions. It's not always a solid in a liquid. There's different kinds. So, one of your essential questions, how do I separate mixtures? I can use a filter, I can distill something, and I can crystallize something. What I want you to know is when do you use each one. So, filtration uses something that's porous, so it has holes inside of it. Might be larger holes, might be smaller holes. To separate a solid from a liquid in a heterogeneous mixture. I can use a filter for coffee. A coffee filter would be an example. I can filter salt out of water. That would be an example. I can also use filters for solid-solid mixtures, like if anyone lives on a farm and you're grinding feed, I can use it to separate or make feed. I can use it when I grind hay, you're going to use a filter. So solid from a liquid or a solid from a solid. It's based on size of particles. So the solid, the salt, is a much larger particle than water molecules, so the salt is taken out. Distillation is used specifically for homogeneous mixtures, and it's based on boiling points. So if it's based on boiling points, it's going to be used for liquids. Moonshine, distilling. Alcohol boils at a very low temperature, so the alcohol is going to boil off before other substances do. So distillation is typically used for liquids using different boiling points. Crystallization is the one that maybe you haven't heard about. It's again for homogeneous mixtures, and it forms solid particles from a solution containing a dissolved substance. So I can take, and here a lot of times the solution has to be pretty saturated, but I am going to maybe add something to this mixture that's going to cause these solid particles to form inside of the solution. These two definitely more common in what I would call the normal world. Crystallization used probably more so in science laboratories and things like that. Not a lot, obviously, well not obviously, but most likely you have not ever used crystallization for anything. A couple other ways. Sublimation, which is a term used when we talk about phase changes. So sublimation is the process of a solid changing directly to a gas, and you can use that to separate solids if one of them sublimates. So for example, CO2 can be frozen. And when CO2 is frozen, it's going to change directly to a gas. You can get this at the grocery store sometime. Dry ice, solid carbon dioxide is dry ice. So it's going to become a gas instantly. So sublimation can be used if one of the solids will actually sublime. And then chromatography, forensics, we do this. It's a technique that separates the components of a mixture based on how they travel. So I can take a black marker and I can make a line on a piece of filter paper. Well, let's use black. If I have a black marker, I can take a line, draw it on filter paper, put it in some rubbing alcohol, and as the rubbing alcohol soaks through that paper, it will separate that ink into all the different colors. So I might have like a really dark blue, and then I might have some purple. I might have a pinkish color that is part of that pen. And what it does is it separates then that black ink into all the different colors that were inside of it. Gas chromatography, you can also take gases and do that because some gases are going to travel further. DNA fingerprinting, where you see the bands of DNA, basically that would be a type of chromatography because all the bands will travel differently.
High school students, there's a representative from MTI in Mrs. Johnson's room. There's a representative from MTI in Mrs. Johnson's room.
I'll stop there for a moment.